Hi, I'm Alan Willard. I'm a developer relations technical artist at Epic Games, and today I'm going to be demonstrating and talking about how I built this. I just called it Silly Geo for lack of anything better, but it's essentially a really simple twin stick shooter. It lets you drive your ship around, fire at enemies, switch weapons. It's got a few waves built in. It's not a multiplayer game. It doesn't have multiple rounds or anything. It's just got a very simple mechanism to track how many enemies you've killed, advance waves, and then tell you if you've won or lost at the end. So I did this about a month and a half, 2 months ago. So I may have a few things that I don't actually remember how I did, which I'll live. So I'm going to actually look at the level. So the first thing you're going to see is I made a grid material. Now this is a translucent grid. I just put two of them above one another so that you'd have a little bit of a parallax feel to give the world a little depth. And then I built this really simple modular set of walls. There's no complex behavior here. I literally just dropped them in place, moved them around. I made a couple of materials that let me change color so that you could have different shapes, different appearances. The whole thing I wanted to do with this was make sure that as much as possible the assets that I used were from the starter content. So really simple shapes, reusing a bunch of the same thing in a lot of ways. And since I am the one who originally built a lot of that starter content, I actually knew what a lot of it was and where to find it. The next thing I did was drop in blocking volumes. This is to make sure that the entire perimeter of the level had collision, so that when I put my navigation mesh in, I would get a really nice fit to my level. So I'm not using the navigation for navigation of the enemies. I'm actually using it as kind of a guideline for where I can spawn enemies. So it's more like a valid bounds of the world than the actual AI behavior beyond where to spawn. The next thing I started working on was the player. So rather than break it all down and hope that everybody remembers it, I'll go ahead and play it really quick. So here's myself as a player. In this mode, the WASD keys will let me fly around. I've got a number of creatures that have spawned and are chasing me down. Mouse wheel will change the current weapon, and everything's color-coded. If I shoot a red enemy with a yellow weapon, nothing will happen. It'll impact and bounce off, but nothing's going to actually decrement the number of enemies in my scene. So you have to match the color of the current enemy, whittle them down to none left in the current wave, and then it'll start the next wave. And the waves all have different colors of enemies. So the second wave has blue and yellow. The third has red and green, I think. You can tell I'm really really well practiced on what my own little mini game here does. Yes, thank you for laughing. Yeah, so red and green, and each of the enemies, they're all based off of the same base enemy blueprint that I created. So I treat that as a parent class, and then I can override individual behaviors for each subgenre of enemy. And there I've one. So jumping back up, the first thing I built was my player, and he took a little while to build correctly. So I've got my player controller, and this is where I do things like if he dies because you've been hit by enough enemies, I turn off input. Here I'm taking input from, in this case it's the left stick, and if this is moving, I add that to the movement input for the player. So this way I have one stick, or in this case the WASD keys, are driving the movement but not rotation or anything of the player. So this is sliding the player around. Now the player is set up to be on a plane. You can see here I'm also looking at the different elements of the graph. There's very little setup in the controller. All I really wanted was the rough course movement of the player to be driven here. And then going into the player himself, here's where some of the more complex behavior comes in. So in my component list, I've got my camera, which is always looking straight down. And from its perspective, it sees the component list that makes up the player. So I've got his movement component, and this is constrained to the XY plane in space. So I've got constrained to plane turned on, and I tell it the normal of the plane. So I know that Z up means that I can move left and right, but I can't move up and down. And then I have snap to plane at start. So I'm going to start everything on the same vertical position so that hopefully my player and my enemies and everything interact with one another. I've then got my default player mesh, which is this little round puck in the center. And that's got the wings attached to it. And the wings are what I call the weapons. So whatever color and shape, that defines which one you currently have selected. And then here we've got things like the camera. And the way I've built this is I have the player center himself, and then I've got scene assets targeted off of that. So if the player moves, it drags these other handles around, and then I can move things relative to that point in space to make sure that everything always lines up. And that's where I do things like the camera and also the sparks that appear in the world. So when you're actually playing the game, there's a star field that you can see which moves as I move, and rather than making a huge one that fills the world, I just create those particles around the player. So as the player moves, he's creating new particles ahead of him. I can also push particles away from the player's origin, and that's all done in Cascade. But it's attached here and turned on and off based on the player's behavior. I also have the reticle, and the reticle by default is invisible, and then as you move it in a direction, the reticle appears and shows you what you're shooting at. So basically, all of this is the setup for how my player is going to act in the world. And then when I actually start the game, I have an event that is, here's the new player. It sets his health back to his maximum. It turns on input. It activates the spark particle in the world and the trail behind the player. So as he moves around, it leaves a streak. It then makes sure that the game state is my little geo game, and then it gets the player controller and sets that up, and then it starts this regen timer. Timers are fantastic. I use them all over the place because you can start it, you can reset it from anywhere within that blueprint, and it allows you to do something frequently without causing yourself the overhead of having something tick all the time. So it's really useful for doing something like my regen, which is going to happen all the time, but it's not going to happen every second, or it's not going to happen every time the engine updates. So inside of regen, I'm starting the regen loop. I look to see if the player's alive. As long as he is, then I look to see, is he less than maximum health? If he is, add a little bit to it and set that to be his current health until we reach his maximum, and then set the final result to be his health. And this is going to continue to loop unless the player is dead, in which case it's going to just disable the entire timer. And like I said, you can set and clear timers from anywhere, so this gives you a really convenient way of setting something up, let it run until some condition changes, and then clear it and go back to whatever it was you were doing otherwise. So here's where we're taking the X and Y input from the gamepad and making a vector and inputting that as movement as well. So this is taking stick input and also things like mouse and keyboard. Here we have, if you've been hit, we're going to decrement your health. So we're going to basically do the exact opposite of the regen. If that takes your health below 0, you're going to branch and say, hey, I'm going to turn off input. I'm going to call that player dead, which is calling back to that controller, which is here. So the player's dead, so we're going to disable that input. And then back here, we're going to print you died and set the player not being alive inside that GeoGame state that we were referencing before. You'll notice I've got a bunch of different collapse nodes here, I find this is a great way of having a lot of complex behavior that you can kind of easily flip through without actually committing to working through the entire graph. So the wing and weapon orientation, every time there's a rotate weapon event, it looks to see if the stick's moving. If it is, it deactivates the mouse. So we're basically context switching between different input styles. If you're using the mouse, it disables the gamepad. If you're using the gamepad, it disables the mouse. We also take the mouse and stick aim vectors, and if you're using the mouse or the game stick, it uses that, and this is where it sets up the reticle. So essentially, when you move the aiming stick, you are moving an object away from the player in whatever direction you're sticking. I then find that position and rotate towards it, set the reticle to be in that position, and if the reticle is further than a little bit away, we make it become more opaque. So as you push the stick, the reticle comes into view, and the player will orient towards that point, and when we get to the firing stuff, if you've moved far enough, it will fire at the stick, or at the reticle. So here we have, if it's true, if the stick is moving or the left mouse is down, so if we're clicking to fire, we're going to fire the weapon, which is another event inside of my player, and then we're going to ultimately set the rotation of the wings to the reticle, which is what's going on here. We've figured out which direction the reticle is based on the stick movement, and we're orienting towards that. And then here we have, and I'm just kind of progressing through all these things as I encounter them. I wanted the camera to zoom out as you move. So the faster you move, I wanted to essentially be able to see more. So you'd be able to see where you're going and not get blindsided by enemies quite as quickly. So I looked at the velocity and figured, okay, I can take that as some kind of interpolating value between not moving at all and my maximum speed. Given that, I take that as a vector length, which is my maximum velocity will be 600 because that's what I set up in my camera, or in my movement component. And then I created a curve, and that curve value just looks like this. So it's a really simple Bezier curve from 0 to 1 over an intensity of 0 to 1. So I end up using that as a lerp from wherever I started, which 0, so wherever the camera was initially placed, to 400 units away, because that felt like a good distance. Every time Shelly cuts, I'm doing this. I swear, it's like, I'll just do this the whole time while I'm not on camera, and you can trust that that's what's going on. So yeah, I lerp between 0 and 400. I make that the z-vector, and then I set that as the relative location for the player camera. So again, if you're playing the game and start moving, that lerp in and out is being driven by how fast I'm moving and that curve that I defined. And the nice thing with this is if I wanted to plot a different curve, I could change this in any way I want and then just change out that variable and it would work. So going back a bit, so here's where has the mouse been clicked? If it has, then we're going to use the mouse instead of the stick. So the weapon switching, I wanted the on the stick, I wanted the bumpers to be. There you go. On the stick, I wanted the bumpers to switch you back and forth between weapons, and I wanted the weapons to be easily defined. So inside of my weapon switching graph, I have an input action, which is next weapon and previous weapon. All that is defined in the project. I have an input, which is called next weapon, and I told it which keys or behaviors or axes or whatever I wanted. That's what I wanted to be the result of that input. So in my project settings, we have input, which I can't open here because I'm not in the right project. Oh well. But yeah, inside the project settings, I have. I will try to make that the last time I do that. No, I'm not doing that either. Inside of the project settings, we define all of the input mapping. If you want something that is on fire, you can set up a mapping that's named fire and say left mouse button and the A button on a controller, all of that map into that. So then inside of your blueprint behavior, you can just say when on fire is done, get an event. So that's what we're doing with this next and previous weapon here. So here's where we start to get into some of the kind of global mappings. I wanted 4 weapon colors and I wanted 4 enemy colors and to make sure that those line up with each other. So I have an array of weapon colors which are visible here. So I have red, blue, green, and yellow. I know based on the length of this array how many weapons are available to me. I have a wing list array which basically does the same thing except that this is 4 static meshes. Each one of these lines up to one of the wing shapes. And then the material reads that wing color, assigns that color to the wing, and when it spawns, that's where it gets things like what particle system color to apply, what wing shape, and things like that. So here I'm looking to see how long is my array, what current weapon am I on, how far am I going to move ahead in weapons. So every time I press that button, it's going to go up or down 1 weapon, and this is controlling which direction it's moving in that array. And then I'm selecting based on am I above 0 or am I below 0 or am I above the maximum. So I'm making sure that it loops within my valid range. And then I say, is my weapon actually ready to switch? If it is, go ahead and switch, but now you're not ready to switch anymore, so you can't do 3 or 4 rapid switches. And then I have a timeline that controls the little animation for what you see when you actually switch weapons. And this is interpolating the color of the trail over time, the little bit of a expand animation. Go ahead and switch, Shelly. You know you want to see me. Yeah, I actually was doing this. A little bit of an expand animation, so it had a little bit of a cartoony feel. And then also the event that occurs. So at some point it's going to say, now it's a valid time to commit to switching the weapons. And then here we have some material behavior and also setting the color for the particle system. So I don't have individual materials set up for all the wings. I don't have multiple particle systems. And what that meant was that I could add as many wings as I want and only have to author the meshes, because every particle system is shared. I just changed the color for the different weapons. Every wing is a unique shape, but it receives the exact same material. So all the wings will glow, all the wings will inherit the color of the weapon that they're assigned to, and all of that just works nice and globally as a system rather than having to have a bunch of individual things defined. So the handle gamepad and mouse aiming, this is basically reading all of the inputs for the reticle and setting the vectors that are going to be used inside of the other behaviors. So it's pretty much just get the position of the mouse, convert it into a world space, and write that out as a vector, and do essentially the same thing with the gamepad inputs. And thank you, Zach Parrish, for adding the WASD behavior, because I hadn't gotten around to it, and he was kind enough to go in here and add this. So yeah, I have everything kind of laid out so that if something breaks, if I want to increase complexity of behavior, if I want to add something new, I can see where it is all nice and easily. So that's how the player works. Now, the player is obviously only half of it. We need something for the player to fight. So what we have is, for the enemies, I have an enemy spawner and a master enemy, and these are the two most important ones. The enemy spawner is where I handle the individual waves that occur. So this is tracking how many enemies are alive, how many enemies are going to spawn when a new wave begins, and what wave I'm on. So I look to see if we've restarted, and this is setting all the waves to 0, and then it ultimately does reset the waves. The initial setup, however, is we're going to begin cast the game state so that we make sure we're operating with the right set of variables. I'm going to set the number of live enemies to 0, and then I'm going to start a timer that checks to see what wave I'm on. And this is what actually manages the progression from one wave to another. And then there's a timer that looks to see, have we reached the maximum waves, and is it time to restart? So the actual wave progression, every time this timer loops, it executes this wave check, which looks to see, has the number of live enemies reached 0, and are we already ready for a next wave? And then it just indexes, it reads this index and goes, okay, it's time to do this wave, which has a do once, and then begins wave 1. Now, the waves themselves, I didn't collapse, so that I could kind of get a really good overview of them quickly. Here we have the first wave. It sets the wave ready to false, so this is kind of my global flag for are we between waves. It sets the number of maximum enemies, which is defined in a variable here, which the first wave is 20, and then it sets the active wave value, basically generates the enemy pool, and then starts the spawn timer, which is here. And again, I use timers a lot. I love them. They are great ways of managing repeating behavior and having kind of a distributed event system. I want these things to all be operating concurrently within a single blueprint. And here we have yes, get player characters unsafe to call in a construction script. Yes, there is a warning in the compile button. In this case, the blueprint's still going to work though. So inside my wave spawner, I have my number of waves, which this is a function I wrote within my blueprint, which is why it looks like that. So I spawn the wave. I say, of my list of enemies, which wave am I currently, and am I at the maximum wave? So here we looked, is the wave ready, or has it completed? And then we spawn actor. And here's where the fun part comes. Inside that wave 1 enemies list are the actual enemies that I'm going to spawn. In this case, I have my master, red, blue, green, and yellow. So if I add more enemies to this, and say, let's go yellow and green, because this list it's reading from that list. It says, how long is the list? How many entries are there? And then it randomly picks from within that list every time it spawns one of these blueprints. So now that I've changed my default list, I will now get some of each of those enemies. I added everything except blue. So that quickly I can define a custom wave. I can add new behavior. I can, if I added new enemies, they would instantly be visible there. And I can have my own little game going. And then just as quickly, if I go into that wave 1 enemies and clear out those 2 new ones, I'm back down to just spawning red enemies, and it goes. So here it looks for a random point in the nav data in that z-plane, and then makes the transform that the spawn actor function uses. So it looks to see where in the world can I spawn one,